Not so bad? Can we live with that? Okay. Just remember, if you can, try not to walk in front of it. So, what does this turn into? 5 times n plus 5 times 4. So that would be 5m plus 20. Yeah? Okay, there's another one in here. So it's all variables, g times d minus e. So that's like a number times a number subtract another number. So if we remove the parentheses, what do we have to do? Yeah, so that's going to be g times d minus g times e. And I suggested that you change that to the addition of a negative, because when they get more complicated, it's a lot easier to think of everything as one result plus another result plus another result, and then just look at that as positive times negative. So then your answer, if you did that, would end up being plus a negative GE, which is the same as a negative EG, but it still is a negative number times a positive. It doesn't matter which one's negative, because if you have just one negative number, the result is always negative. So if we do something like this here, we model something like that. So length times width is area. That's the whole idea with that. Area is going to be length multiplied by width. So we can call one side the length and the other side the width. So if we express the total area, what we are doing is we're writing the result of the multiplication. So what is x multiplied by x? What's another way of writing that? X squared, yeah. So that's x to the second power. And then if I took this length, which is still x log, times this, which is y, that would be just xy. So if we write it as length times width, we have x multiplied by x plus y. So then if we distribute the x, that becomes x squared plus xy. So this is expressed as the multiplication of the two lengths, or side lengths. This is the total area. And this chapter, in this lesson, asks for some of that kind of work. And you're going to see it on the quiz, too. You're given something that looks like this. It might be a number on one side and then another expression on the other side. And you've got to say, well, this is going to be 4 multiplied by x, and this area is 4 multiplied by 7. So it's some of the same stuff that we've done in the past, but now we just are throwing more variables into it. That's what it's going to become. So what is 4 times x? How could we write that? 4x. And then 4 times 7 is, so we're adding. So again, if it's given to you this way, it's x times x times 7. So it's x squared, 7x. There's the model. There's written as expressions. So that's what we did with lesson 1. Now, with lesson 2, we're going to be looking at adding like terms. So when we look at terms, for example, terms are separated by addition and subtraction. Think of that. So something like x squared is a term, and 7x is a second term within that expression. We can't add those together, because even though they're both x's, this is the second power, and that's only the first power. So just like you couldn't say that 4 squared plus 6 times 4 is equal to something like 6 times 4 times 4 or whatever. We can't do that, or 6 times 8. We can't put those together because we have to consider the exponent, and we have to consider the multiplication before we put them together. So, you know, we did quite a bit with this last year and some the year before with like terms and such. So, let's see if I can. So the big thing that's going to come from this is if you have a big, long expression or an equation even, and like terms show up in different parts of the expression, we want to be able to simplify the expression by combining the like terms. But we might need to use the distributive property first. So like in the first example here, what they give us, this 4 times u plus, when they go in parentheses, they say 2t plus u, then out of parentheses 7t, and then back in parentheses 4u minus 1. Oh no, I'm sorry, 4u minus t. So, oh, sure enough. That's a 5. That's what they gave us. Did I say 4? Yeah. Yeah. Rough start to the morning, crying out loud. The 8th graders. I made them sit up there for 10 minutes because I thought it was nutrition break time before they came down to the room. It's not. You guys just had it. So there we go. So this is what it's supposed to be. And we have to be able to combine the like terms. So which terms are like that if we get them in the right place, we can add them together or subtract them? What would go along with the 4u as a like term? 5u. What else? U. How many u's is just u? 1. And then we've got the 2 t's, the 7 t's, and then that t. So with this problem, we're adding what is in the parentheses to the 4u first. But because we're adding it, we can add in any order. Commutative property says we can add things in any order that we want to. The only problem, and this is going to be the same, this is going to be the same, the only problem is right here where we have a negative t. But if you change that negative t to the addition of a negative number, now all there is addition. So now you can remove the parentheses and just add everything up. So this would just be 4u. Be just like that. And then if you needed to change the order mentally to add them, that's fine. If you need to write it down, that's fine too. But if we look at that, we've got 4u plus u and 5u. How many u's is that? It's 10u. So 10 multiplied by u. And then we have 2t, 7t, and a negative t. So what will that be? What's 2 plus 7? 2 and 7 is going to make 9. Minus a t is 8t. We can't add u's and t's because we don't know what they are. We don't know what we have to multiply 10 by and 8 by, so we just leave it at 10u plus 8t. So that one's pretty straightforward. But then some of these other ones, they end up having a little bit of a twist in them. So for example, the second example, you've got all this in parentheses, and then they have 10, and that's going to be times all of this. So before we can go and add anything, we've got to think about how we can remove the parentheses, just like the first one. But in order to take these parentheses away, we have to use the distributive property, which goes back to the first lesson. Right here, there's nothing in front, so there's no distributing to be done. Everything's addition, so we can just call this as it is without the parentheses. But then here we have to distribute the 10, and it's got to go all the way across. All three terms. Everything gets multiplied by 10. So what I would suggest, again, is changing it to the addition of a negative. That'll make it so when you are done, you have all addition on the bottom, and then you can just add each term. You don't have to worry about what am I subtracting and such. And you can always think of negatives as being subtraction when you're putting it together in your head. But as far as writing it and keeping track of it on paper, addition of a negative. So I'll write it all out like this. When you're doing your work, you might say, oh, geez, I just know 10 times 12 is 120. And you can go right to that. That's up to you. But I'm going to write it right now so that you can see where everything comes from. So then we go across, these stay as they are. So 10 times 12 is 120, f times f. What does this become? 10 times a negative f squared. This is the same as a negative 1 f squared. So 10 multiplied by negative 1 is negative 10. And that's just f squared. And then 10 times negative 3 is a negative 30. So now we just got to figure out what are the like terms and add them together. So remember that like terms will have the same variable and the same power. And some of these don't have a variable, they're just integers, so that can be added together, because we can add numbers like we've been doing for the last 15 years or whatever we've been doing. So we start out, it's nice to start with the highest exponent first. So here's a t squared, but this is an f squared. So those don't get added, do they? They're not like. One is t, the other is f. So we'll just take 4t squared and mark it off. And then I look all the way across and I see another squared. And there are no other f squareds, are there? There's just f to the first power. But just like with algebra tiles, when we had something like this, where this was 1 by x, and this is x by x squared, these are not like, so they cannot be added together. They have to be the same thing. You can't add 2 squared plus 2, or 3 squared plus 3, and come up with like 3 to some different power. That doesn't work. So here we have negative 10 f squared. You could also write that as subtract f squared. Subtract 10f squared. So this is done. And then what else do we have in here which is like? Things that could be added. Yep. F is how many f's? 1 plus 120 is 121 f. Mark them off as you do them. And then we're left with 9 and negative 30, which is? How much is it? 9 and a negative 30 is how much?
Negative 21.
Yes, thank you.
Yeah.
Or you could write subtract 21. Either way is fine. So that's it. That's done. None of these are like terms. Okay, now I remember doing some of this stuff with you guys last year, where we have to start with an expression that doesn't have parentheses and insert parentheses. So the third example does that. We have 8x plus 8y. And what they want us to do is they want us to write this with parentheses. And the trick with this is to look for the greatest common factor in each of the terms. So if we look at these two numbers here, what's the largest value?
64.
That's not, that would be a multiple of 8 and 8. Or, I'm sorry, that'd be a product of 8 and 8.
Or.
So if we're looking for a number that would go into 8x and go into 8y, which each of those would be divisible by, it would be the greatest amount. You could divide this by 4, so we'll write that. So if you divide that by 4, it would be 4 times 2x. And this would be 4 times 2y. But if you look at 2x and 2y, they still have a common factor. 2.
Not about 2.
So here, yeah, if you take this as 8 multiplied by x, this is 8 multiplied by y.
Yeah.
So now, this is the factor that's in common, the 8. So what we can do is we can say that this is going to be 8 multiplied by, and then think backwards. What do you multiply 8 by to get this amount? 8 times what gives me 8x?
8 times x.
8 times x. And then 8 times this has to give me the other term. Yeah, that's your y. So 8x plus 8y can be rewritten as 8 times the quantity x plus y. So that's putting the parentheses in, and what it allows us to do sometimes is to have a way to be able to simplify and divide numbers out of expressions more easily. Okay, so next one, they have 3mz squared and then it's subtract 6pz squared. And they want us to do the same thing here. They want us to look for the greatest common factor. In fact, they tell us what it is, but don't look at that. See if you can see what it would be. So what's the greatest common factor? Definitely a 3. Because a 3 goes in here once and it goes in there twice. So then we can go beyond that. Is there an m in both of these?
No.
No, so that's not in common. Is there a z in both of these? Is there a z squared? Yeah. So the z squared is in both of them, so the greatest common factor is 3z squared. You see, if we were to rewrite this, put the subtraction in here. 3z squared times some number equals this. So what would you have to multiply 3z squared by to get 3mz squared? M. And the second term in the parentheses, 3 times what number gives us 6? And then we've got a z squared and a z squared, but what's missing?
E.
P. So this just becomes P. So 3z squared times the quantity m minus 2p ends up being another way of writing this expression on the top, using the greatest common factor up front. So that's the kind of work that this lesson is. And what am I doing here? Oh, I'm looking at the wrong page. Let's see, here we go, 2, 2. So page 75. This is 21, 22. This just goes to 22. There you are.
I already did that.
You already did this one?
Oh, I am ahead. Oh, I didn't even do that.
You did the 69.
I did 65. And 75, 69.
So you did them.
Yeah, I
So
didn't
what-
think this would be ahead. I was just trying to stay caught up.
If you were caught up, yeah.